Hello, welcome to the quiz review for 3.05. This is actually a quiz that is over 3.04 on the quadratic formula and 3.05 on the discriminant. It's just labeled 3.05 in the OHS. All right, we're going to go ahead and get started with the first question. So it says that Victor is solving the equation 4x squared equals 32 minus 9x with the quadratic formula. Which values could he use for a, b, and c? So remember, when you're solving for your quadratic formula, you want to make sure that it's in standard form. Okay, and standard form looks like ax squared plus bx plus c equals 0. Okay, so it's always equals 0. You want to have everything else on the left side of the equation. So if I look at my equation here, I notice I've got this 32 and this negative 9. So I'm going to have to move that over to the other side of the equation so that everything is together. Okay, so I can start by subtracting the 32 since it was a positive, and I can add the 9x. I'm going to do both at the same time, and I'm going to move them both over to the other side. So that leaves me nothing on the right side, which is what I wanted. And now I'm going to have 4x squared. I'm going to put the 9x next because we want to write it in order, plus 9x minus 32. Remember that constant that's always at the end? That's why I switched the 9x, because I have bx for my middle term up in my standard form. Now we can just label. So we have our a, our b, and our c. So my a is going to equal 4, my b is going to equal 9, and my c is going to equal negative 32. Remember just to keep those signs with your the values that you take out. So since the 4 was positive, I kept it a positive 4. The 9 was positive, positive 9. The 32 was negative, so I kept the negative 32. And that's it for question number 1. You just need to solve it for standard form, find your a, b, and c, and answer your question. So moving on to question number 2, it says to solve for x, and we want to simplify our answer. So this means we might have a square root left over in our final answer. So to solve for x, I'm going to use my quadratic formula, which we have over here. Okay, and just like in the first problem, I identified my a and my b and my c. I want to do the same thing. So my a is going to be that 6. The b goes with the x. That's going to be that negative 9. And the c is the constant, negative 12. Now that I have my values, I can go ahead and just substitute them in for my quadratic formula. So x equals negative b. So I'm going to put that negative, and I'm going to plug in my b, which was a negative 9. Okay, even though the formula is negative, and this is the negative 9, I need to put both those negatives in. Okay, so plus or minus the square root of b squared. So I'm going to put that back in parentheses. My b was negative 9. So negative 9 squared minus 4 times a times c. I'm just substituting in the values, and that's going to be all over 2 times 6. Now I know some of you are great at just plugging this into your calculator in one step and getting your answers, but you'll find in this case you're going to get decimals if you don't have a calculator that simplifies those square roots for you. So I'm going to go ahead and walk through the steps on how to simplify this. So 2 negatives we know makes a positive, so this is going to turn into a positive 9, plus or minus. Okay, negative 9 squared is 81. And then we need to multiply. So negative 4 times 6 times negative 12 is going to give me 288, and that's a positive. 2 times 6 is 12. Okay, so we can simplify this one more step. 9 plus or minus 81 plus 288 gives me 369. All over 12, and that's the square root of 369. All right, now the square root of 369, if you have the awesome TI-30XS and you just type that in, it's going to simplify it for you, and it's going to tell you that the square root of 369 simplifies to 3 square root 41. all over 12. Okay, now if you don't have that, you are going to have to break this up. So the square root of 369, you need to find factors. So I tried 9 and 41. 9 breaks down into 3 and 3. 41 does not break down any further, and I have one set of primes, the 3s, so that's why the 3 came out, and I'm left over with the square root of 41. So that's how you would do it by hand. Now lastly, I want to see the 9, the 3, and the 12. Since this is divided by 12, these do have a GCF, so I can factor out a 3 from all this, or divide a 3 out. So this would become 3 plus or minus the square root of 41, all divided by 4. It's going to be my final result because I can divide a 3 into each of these terms. 3 goes into 9 3 times, 3 goes into 3 once, and 3 goes into 12 4 times. And this would be my final answer, simplified. All right, so that takes care of question number 2. I'm going to move on to question number 3. All right, in question number 3, it says use the quadratic formula to solve x squared plus 13x minus 7 equals 0. What are the solutions to the equation? This time it says to round irrational solutions to the nearest tenth. So those of you who don't like that whole simplifying process, this question is for you because you just get to find the decimals. Okay, so first step, we need to find our A, our B, and our C. So my A, I don't have a coefficient out front, so that really means that it's a coefficient of 1. With my x term, that is our 13, and then my C is going to be that negative 7. And again, I'm getting that from our standard form, which looks just like this. So that's where I'm getting my A, B, and C from. Now we can go ahead and substitute everything in. So x equals negative b. So negative 13 plus or minus the square root of b squared, so 13 squared, minus 4 times a, which is 1, times c, which is negative 7, all over 2 times 1 because a was 1. Okay, again, we're just literally plugging in each of those values into the formula. Okay, so again, if you like to just plug this all in one step, feel free to do so. Otherwise, you can simplify with some steps. So I'll do the steps here. So 13 squared is 169. And then we have negative 4 times 1 times negative 7 is going to give us a positive 28. 2 times 1 is just 2. So when I simplify this, I get negative 13 plus or minus, and then 169 plus 28 gives me 197. And remember, that's in the square root. All over 2. Now we're just going to find the answers. So that says to round irrational solutions to the nearest tenth. Okay, tenth, that is 1 decimal place. Remember, this is really 2 problems. This is negative 13 plus the square root of 197 over 2, and it is negative 13 minus the square root of 197 over 2. So I'm going to find each of those answers by plugging them into my calculator. So negative 13 plus the square root of 197 divided by 2 gives me 0.5 if I'm rounding to 1/10. And if I do that same thing, negative 13 minus the square root of 197, all divided by 2, that's going to give me negative 13.5. And those are my 2 answers, rounded to the nearest tenth. All right, so that wraps up question number 3. Question number 4 we're switching gears and we're going to be looking at some discriminant problems. So here it says, how many and what type of solutions does the equation have? So we have to use our discriminant formula, which is our negative, nope, we don't. Forget what I just said, our discriminant formula. I was working on the wrong lesson, is just the inside of our square root. So I'm going to write out our quadratic formula here. I forgot to copy and paste this from before. Okay, and the discriminant part is just the part that's underneath the square root. Okay, so we're just looking at the b squared minus 4ac. This is what we're looking at for the discriminant. So if we notice over here, our equation that we're given, it's not in standard form. Remember, that's always going to be our first step. We want it to be in standard form. So I'm going to go ahead and subtract the 12c over and add the 10 so that I get a 0 on that side. So I'm subtracting the 12c, adding the 10, and then I just write it in order. So 3c squared minus 12c plus 10. So my a is 3, my b is negative 12, and my c is 10. A, B, C. Now I'm just testing the discriminant part to see what type of solutions I'm going to have. Okay, so my b, if I'm using this formula, b squared, negative 12 squared, minus 4 times a, which is 3, and c is 10. So let's go ahead and simplify that. Okay, so negative 12 squared is 144, and then 4 times 3 is 12, times 10 is 120. And when I subtract those, I end up with a positive 24. Okay, so I'm going to go up to my little handy chart up top here and see that, oh, that's black, that's not going to help me highlight there. We can see that that's a positive solution. Okay, so we know that we're going to have two solutions. Okay, and we want to know what type of solutions they are. So are they rational or are they irrational? If they're rational, then this answer would be a perfect square. But if we take the square root of 24, we get a decimal. So it's not a perfect square. So if not a perfect square, it's going to be irrational, which is the case for the number 24. Okay, so we know it's irrational because it's not a perfect square. So my answer, two solutions that are irrational. All right, so that wraps up question number 4. Let's move on to 5. So this just asks what the discriminant d is of the equation. Okay, we don't even have to test the types of solutions, we're just finding the discriminant. Remember that the discriminant, again, that's the b squared, let's change colors here, b squared minus 4ac. That is how we find our discriminant. So we need to find our a, which in this case is 1, our b is going to be negative 5, and our c is going to be positive 13. And I'm simply going to substitute those values in right here to this formula. So b squared, so negative 5 squared, minus 4 times a was 1, times c, which was 13. Negative 5 squared is 25, and then 4 times 1 times 13 is 52. 25 minus 52 gives me negative 27, and that is our discriminant. We don't have to apply to see what types of solutions we have, although if we did, it's a negative, so we know that it would be no real solution because it's a negative under the square root. All right, so that wraps up your 3.05 quiz review. I hope this helps. Good luck, and we will see you next time.